Hi guys, welcome to another episode of Learn with Sir Glenn. For this video, we're going to discuss polynomials and the related terms. Okay, so let's go! Polynomial. A polynomial is an algebraic expression consisting of variables and coefficients that involves only the operations of addition, subtraction, multiplication, and non-negative integer exponentiation of variables. Since a polynomial is an algebraic expression, it is important to know how to tell if an algebraic expression is a polynomial or not. And an algebraic expression is a polynomial if it satisfies the following conditions. So first condition is non-negative exponent on your variable. So if you have 2x raised to 3, this is an example of polynomial, whereas 2x raised to negative 3 is not a polynomial. The reason is because you have a negative exponent which is negative 3. Second condition is no fractional exponent. So for this one, we can have 2x raised to 4 over 2 is an example of polynomial. So although you have here an exponent which is in the fraction form 4 over 2, since you can still simplify this as 2, then you still consider this as polynomial. Whereas if you have 2x raised to 1 half, since your exponent is 1 half, and it is a fraction, then this is not a polynomial. Third condition is no variable inside the radical sign. So let's have square root of 2x squared. This is still a polynomial because your square root applies only to 2. So therefore, you don't have variable inside the radical. But if you have 2 square root of x, then this is not a polynomial because x, which is a variable, is inside the radical square root. Then fourth and the last condition, no variable in the denominator. So 2x over 3 is an example of polynomial because although you have your denominator, since your denominator is 3 and it is not a variable, then it still satisfies the fourth condition, which is no variable in the denominator. But if you have 2 over 3x, since x is on your denominator and x is a variable, then this is not a polynomial. So let's try this. Identify if the given algebraic expression is a polynomial or not polynomial. So let's have 2x squared minus 4x plus 2. So this is an example of polynomial since it satisfied all our 4 conditions. So no negative exponent, no fractional exponent, no variable inside the radical, and no variable on our denominator. So this is an example of polynomial. Let's have another one. So 4x cubed plus 2x raised to negative 3. So obviously this is not a polynomial because of our negative exponent, which is the negative 3. So let's have 2 over 3x plus 3. So this is a polynomial. So although you have your fraction, since your denominator is not a variable, still consider as a polynomial. Then we have square root of x plus 5x squared. This is not a polynomial since we have a variable inside the radical. Then let's have 4x plus square root of 3 plus 5x squared. So this is a polynomial. So although you have your radical sign, but if you're going to look at inside the radical, it's not a variable, so therefore it's still a polynomial. Let's have the last one. X raised to 1 half plus 2x minus 4. So this is not a polynomial because of our fractional exponent. So polynomial is actually composed of 2 words. So we have the poly meaning many and nomial in this one meaning term. So therefore, we can say that polynomial is an algebraic expression composed of terms. And when you say term, it is a single mathematical expression composed of a variable, a constant, or a product of constant and variable. There are actually types of polynomial according to the number of terms. So we have first the monomial. This is a polynomial with only one term. For example, you can just simply have 2x squared or x or 2. So those are examples of monomials. Then we have the binomial. So this is a polynomial with two terms. So for examples, we can have 2x squared plus 2, x minus 2, or x raised to 4 plus 2x. So these are examples of binomials, polynomial with two terms. Then we have the trinomial, a polynomial with three terms. For examples, we have 2x squared plus 4x minus 2 and x cubed plus 2x minus 5. Only have here three terms. Then we have the multinomial. So these are the polynomials with 4 or more terms. So for example, you can just simply have 2x raised to 5 plus 4x squared minus x minus 2, a polynomial with 4 terms. And another one is 4x raised to 5 minus x raised to 4 plus x cubed plus 2x minus 5, a polynomial with 5 terms. So these are examples of multinomial. In studying polynomials, there are terms that you have to remember. So a polynomial in one variable are algebraic expressions that consist of terms in the form a sub n x raised to n plus a sub n minus 1 x raised to n minus 1 and so on up to a sub 1x plus a sub 0. So the first is the degree. The degree of the polynomial in one variable is the highest exponent in the polynomial. Then we have the leading term. In a polynomial, the leading term is the term with the highest power of x. Then we have the leading coefficient. The leading coefficient of a polynomial is the coefficient of the leading term. Then the constant term. The constant term of a polynomial is the term of degree 0. It is the term in which the variable does not appear. So let's have this example. So suppose you are given a polynomial in one variable, 2x raised to 5 plus 3x cubed minus x squared plus 1. So the degree is the highest exponent on this polynomial, so therefore it is 5. The leading term is the term with the highest power of x. So for this one, since the degree is 5 and the term with the exponent 5 is 2x raised to 5, so therefore the leading term is 2x raised to 5. The leading coefficient is the coefficient of our leading term. So since our leading term is 2x raised to 5, the leading coefficient is 2. And the constant term is the term in which the variable does not appear. So here on our given here, it is the positive 1. Okay, so let's have another example. So negative 5x cubed minus x squared minus x. So the degree is the highest exponent, so that is 3. The leading term is the term consisting the degree, which is negative 5x cubed. The leading coefficient is the coefficient of the leading term, and that is negative 5. And the constant term is the term that has no variable. For this one, since there's no term without variable, the constant term is 0. So let's have negative x cubed minus x squared minus 2x raised to 7 minus 5. So if you're going to identify your terms related to polynomial, it's better to have your polynomial arranged in descending power of x. So for this one, we can have negative 2x raised to 7 minus x cubed minus x squared minus 5. So arranging your polynomials in descending power of x. So now we can now identify the degree, which is 7. And the leading term is the term that consists the highest exponent, which is negative 2x raised to 7, the leading coefficient, which is negative 2, and the constant term, which is negative 5. So after identifying the degree, you can actually name the polynomial according to its degree. So let's have the first one, which is the constant polynomial. So this is a polynomial with degree of 0. An example of this is 3, a constant term. Next, we have the linear polynomial. So this is a polynomial with degree of 1. So for example, you can have x minus 2. Then the quadratic polynomial. This is a polynomial with degree of 2. So for example, you can have 2x squared plus 2x minus 1, a polynomial with degree of 2. So next is cubic polynomial. So it is a polynomial with degree of 3. Then an example is x cubed minus x squared plus 2. Then we have the quartic polynomial. Polynomial with degree of 4. For example, you have x raised to 4 plus x cubed minus 2x squared minus x plus 1. Then the quintic polynomial, a polynomial with degree of 5. Let's have an example. 2x raised to 5 minus 3x cubed plus 4x squared plus x minus 1. Then after this, you can just simply have nth degree polynomials. So these are the polynomials with 6 or more degrees. So for example, you have x raised to 7 minus 2x squared plus x minus 1. So you can just simply say that this is the 7th degree polynomial. Okay, so that's it. We're done. Thank you for watching and hope you have learned something from this video.